We're going to talk about Spring Cloud Gateway and API gateways a little bit. My name is Spencer Gibb. I, of course, work for Pivotal on the Spring project.
Hello, everyone. I'm Sree Tummidi, and I'm the product manager for Cloud Foundry UAA and the single sign-on service. I've been with Pivotal for 3+ years, working on open source and proprietary offerings. My main area of expertise is enterprise security, and prior to Pivotal, I was with CA Technologies working in the identity and access management and the API management space. Oops, what did I do?
There you go.
Oh, yeah. Okay, so let's start out this session by discussing what is an API gateway. But before we even answer what is an API gateway, let's try to understand what are the different sort of industry trends leading to an API gateway architecture or an API gateway pattern. So all of us are aware that enterprises have been on a journey in the past decade in terms of becoming more open, and the boundaries have shifted. So there are different trends leading to this kind of a shift. So there is the mobile trend, there is the cloud trend, and also obviously the microservices trend. So all these are leading to a different sort of set of problems in terms of how microservices can be managed in this new architecture. And API gateway plays a key role in that management aspect, and making it simpler for the clients on the other side. So by clients, I mean different applications that need to consume these microservices and APIs, and what role an API gateway has to play in that particular flow.
And that link that was on that slide is Chris Richardson's definition of API gateways. So we'll give you the link to where these slides are, and you can check out that link.
So this particular graphic basically explains like a typical microservices architecture. So if you have like a traditional enterprise application and you break it down into smaller, lightweight microservices, in this case, it is an online store, and it has been broken down into 3 different services. Now, I read this as, like there is a left-hand side to the equation and there is a right-hand side to the equation. On the right-hand side, you have like these different services which, or an application which has been broken down into smaller services, right? But what happens on the consumption front? You still have an application or a set of applications which need to get resources or get information from the enterprise, but the architecture in the back end has changed. Now, do you expect these applications to now redo the whole sort of process in terms of how they interact with these services and with these APIs? The answer is hope not. You don't have to do that, and that's where API gateway comes in, because API gateway creates a layer of abstraction in terms of how these services can be consumed in a consistent manner without having to change a lot of things on the client side. So with a microservices pattern, like you are looking at 3 services here, and all these 3 services make up a business flow, right? So over here, API gateway traditionally, like it does a lot of aggregation as well. So as a client, if you want to load a specific set of information, then what the API gateway can do for you is it can aggregate that information so that a client doesn't have to make all those 3 calls or all those 5 calls. So apart from that, I mean, we all know that we use different kinds of devices, like we use mobile devices, and we use devices of other form factors. So you have different kinds of applications, so to speak. So each application has different needs in terms of the kind of data that it needs to consume and in what format. So API gateway is sort of capable of presenting the data in that format to a given application. So if it is a mobile application, it could be rendering like a JSON with a certain kind of schema, as opposed to a web application, which may need a different kind of layout or a different kind of information presentation layer. So Let's take a quick look at the sort of the standard responsibilities of an API gateway. So from the previous picture, you all can make out that it needs to perform different kinds of routings. So apart from like the standard routing wherein, like if a client needs to talk to a service and the API gateway is responsible for routing to that service, but beyond that, there are other sort of routing capabilities that can be exposed via an API gateway pattern. So one of those is surgical routing. So basically surgical routing is akin to like a dynamic routing wherein based on the kind of request, it is decided as to where to route the request. So, like there are different aspects of the request. You have headers in there, you have different parameters in there, and based on that, you can decide where to route the request. So a good sort of business use case is, you have geolocation, and based on that, you need to decide where to route the request. Beyond that, like you have canary-based routing also, wherein if you want to introduce like new set of capabilities, which is a different API version, so to speak, but you do not want all the traffic to flow to that new version. So you want like some kind of, a split, wherein say 80% of the traffic goes to like the old version of the application or the current version of the application, and 20% of the traffic needs to go to the new version of the application. So you can do things like A/B testing. So that API gateway pattern makes that possible as well. Beyond that, when you're working like in an enterprise, the reality is that not everything can move into like a microservices pattern immediately. Like you would want to do that, but that's not the reality. So when you're working on moving towards like a microservices strategy, you may not want to just take the entire sort of application and split it into microservices in one go. So you want to do it in a phased approach, wherein only some parts of the applications are broken down into lightweight microservices, whereas say like the major portion of the application stays as is. So API gateways can make that happen as well, wherein only like a subset of that monolithic application is broken down into services, or newer services are added to that, whereas you continue to sort of route to the old application. So that's referred to as the monolith strangling. Beyond that, another sort of important aspect of API gateways is pushing a consistent security policy. So when you split an application into multiple services, you still have to deal with enterprise security and compliance needs, and things like authentication, applying standard authentication and authorization policies and practices. So imagine, like you have broken this down into 20 different lightweight services. How are you going to sort of secure all those communications? So an API gateway can make that possible because it's potentially like the single entry point which can be leveraged to perform different security filters and security patterns. So things like authentication, authorization, rate limiting, and throttling are like the different sort of security features that you can add within the API gateway. And the benefit to the developers is that they don't need to worry about security anymore, but the greatest benefit is to the enterprise security posture because a consistent security policy is pushed. So let's talk about some gateway types. So the gateway pattern has evolved over time. I mean, as I mentioned, like this, these trends and their adoption in the enterprise, and how the enterprise companies have reacted to these trends and come out with products. So the oldest type that you could refer to in API gateway pattern is that of an appliance. So I think you all are familiar with like an F5 load balancer. So appliance can be hardware or software based, but since this predates the whole sort of microservices trend or the move, it doesn't have like full-featured API management and API gateway capabilities. So like an F5 load balancer is something that could potentially give you like basic load balancing capabilities at layer 4 and layer 7, but not things like surgical routing and like monitoring capabilities or other security features. Another Another kind of API gateway architecture is software as a service. So as the name suggests, like it's API gateway functionality packaged as a service. So obviously the greatest benefit with software as a service is that you do not need to run and operate this API gateway. All features are vended as a service. A good example of it is Apogee's Edge and also Amazon's Elastic Load Balancer. So there are pros and cons to SaaS approach. So obviously the pros are that you don't have any sort of operational overhead, and you get like the latest and greatest capabilities that the service offering has. But anytime you choose this model, one thing that you should keep in mind is where your applications and APIs are running, because there is a latency factor introduced. So if your SaaS and your APIs that need to be managed or microservices are in the same cloud, then you don't need to worry that much about the network hops and the latency. But if things are running outside or in a different cloud, then you do have to look into that aspect. The next type is a web server. So there are different open source versions available. So there is the Apache mod proxy, and there is also Nginx and HA proxy. So they give you basic sort of API gateway feature functionality. Something like Nginx has been further improved by Kong API gateway, if you've heard about that. It's open source, and it basically sort of leverages the Nginx capabilities, and it provides like an API gateway product which can be easily extended through a plugin-based approach. So depending on the kind of functionalities that you want to implement using the API gateway pattern, those can be introduced as plugins. Finally, the mesh. So the mesh model is pretty recent. In a mesh model, it's not so much of like a central point through which all requests are flowing, and you have like some kind of a central enforcement point for all the different API gateway patterns. A mesh model is more distributed. So a mesh model makes more sense when services, the microservices themselves, have to communicate with each other. So it's not like this one-way north-south kind of communication, but more of a east-west communication in network lingo. So think of a scenario wherein you have a bunch of microservices, but they all need to interact with each other. So that creates like a service mesh, so to speak. So in that particular scenario, the gateway architecture is more distributed. So you have like a lightweight gateway agent sitting next to like a API or a set of APIs, and it's referred to as a sidecar. So there are some reference implementations of this kind of API gateway architecture, because you still have to solve the same problems, like how do I get a common routing pattern and a common security enforcement layer. So some reference implementations are Istio and Linkerd. So Istio is a project that has been started by Google, and it's open source, and Linkerd as well. And Linkerd also has like a integration with the Istio model. So you can Google all these terms and to read more about that.
Has anybody heard of Envoy from Lyft? A few of you. That's the
Istio
the router that is included in Istio.
Okay, so we all are at a Spring conference, and I have not spoken about Spring yet. So there's the logo, and the session today is about Spring Cloud Gateway. I just wanted to give you like an overview of the pattern itself, but what are we doing in Spring? Like, how are API gateway patterns implemented in Spring? Everyone knows that Spring is widely used in the enterprise. It's a developer-friendly framework, and it's very easy to sort of extend and customize. So Netflix, right? It came out with Zuul, which is a proxy or an API gateway, as a better term. If you click through that link that Spencer has put in there, it walks through like the history of why Zuul came to be. So just to give you like a quick summary, if you don't want to watch the video, Netflix in its initial days, like any other enterprise, it wasn't like cloud ready or anything, because their needs of the customers and the kind of scale that they wanted to run at were not really what they are today. So, but as they evolved, right, like, so they went from like this on-premise data center like model to like a public cloud model, because they had those needs around scale and also around the different kinds of devices that had to be supported. So, like it could be an iPhone, an Android device, or the whole gamut of, like television sets and the video game consoles. So they had to deal with the scale and with the device types. And initially, right, they were using Apigee and Mashery, but soon they realized that API gateway is a core part of their strategy and their product offering. So they came out with Zuul, and Zuul is was initially sort of adopted on the Spring Cloud side as well, and a lot of contributions were made to that project. But the major drawback of Zuul, at least Zuul 1, is that the calls are blocking. It's a blocking I/O. It's based on the servlet API, and another problem is that it's not that developer friendly. So it's hard to sort of extend that to fit your needs. Netflix, I believe last year, announced Zuul 2, and they made another sort of like a public talk or announcement in September. Right now, Zuul 2 is 2.1.
Yeah.
And the major sort of difference between Zuul 2 and Zuul 1 is that Zuul 2 is non-blocking I/O based on RxNetty. And with Zuul 2, the major motivation was to have that non-blocking connections or connectivity, but then beyond that also support HTTP2 and WebSockets. So, so this is what Netflix is doing with regard to Zuul 2, but major problem with between Zuul 2 and Zuul 1 is that there is no backwards compatibility, so it's like a net new project. So if you were to like use Zuul 2, then it's literally a major rewrite for you in order to consume that. So with that, I'll hand it over to Spencer to walk through the Spring Cloud Gateway.
Thank you, Sree. So a year ago, any folks from Colorado here? Couple? All right, so I was at a defrag in Boulder and thinking about the future of, so we had heard this announcement of Zuul 2, and that was neat, but there were some things that were kind of working in my mind, and I came up with at the time, a little bit controversial idea to not use the next version of Zuul as the replacement for Zuul 1, which suffers from these problems that she talked about. And part of the motivation was that there was a lot of wheel reinventing happening in Zuul that Spring Framework takes care of. I'll talk a little bit about that. And so I put out this idea, and it was generally liked by the folks from the team, and so I started working on it, and it's grown right along with WebFlux and some of the other technologies that you've probably heard about. So Colorado is the birthplace of Spring Cloud Gateway, if you're wondering. So it's built on Spring 5, so Java 8, Servlet 3.0. Of course, we won't be talking about Servlet today. We'll be talking about Project Reactor. It's built on Spring Boot 2. So people ask me, when is this going to be released? Well, after Spring Boot 2 is the answer. Notice I didn't give you a date. So this is built on Project Reactor, and I specifically built on this hoping that I would get benefit from it. And as I was developing the project, these benefits became clear. So let's see. Anybody attended a session on Reactor today? How about WebFlux? Okay, a number of you. That's very good. So you've heard a little bit about this, right? Reactor is non-blocking. It has back pressure, runs in an event loop, right? So there are only a handful of threads, right? Roughly one per core in a machine, and things get queued. And kind of at the end of the chain, we make the network call, and as the response comes back, we pass that back out. And that was really important because we wanted to be able to support some of these features that require long-lived connections, right? She mentioned them, HTTP2 and WebSockets, right? That just doesn't happen. So I follow the issues in Zuul's issue tracker on GitHub, and I think 1 out of every 3, I have to say, this is not the Spring Cloud repository, make an issue somewhere else. But a lot of times, there's a repeated question, hey, does this support server-sent events? Does this support WebSockets? And the answer is just, no, it doesn't. And so we wanted to be able to do that. So one of the things that I've noticed in this is it's very easy for blocking calls to creep into Reactor code. So I got an issue a few weeks ago now that said I was doing some load testing on the gateway, and I have all these blocking calls, and it's really slow. And I was like, oh no, what did I do wrong? Well, it turns out logging by default is a blocking call, and I had some log statements in there. So I removed those, and the issue was gone. But it's very easy for that to happen. So the other thing that we're built on is Spring WebFlux. So I'll just answer the question right now. Yes, you have to use WebFlux to use Spring Cloud Gateway. We could potentially do a Frankenstein MVC Spring Cloud Gateway thing, but we'll probably hold off on that for now. But we get a lot of things for free that in Zuul 1 we had to replicate out of the Spring ecosystem. We get handler mappings, right? This is the mechanism by which the Spring dispatcher says, where should I send this web request to? What code should run this? We get filters, right? Here is a web request. I need to do some things to it. The predicate class from JDK, right? I need to run a test. There's a consistent interface for that. Server Web Exchange. If you went to the WebFlux talk, you may have seen this. This is the entry point object into the HTTP request and response. And also we get some path matching stuff, right? So if you've all written an MVC request mapping, right? You've put the little curly braces, and we'll show you that. But you can get path matching and then use those matched things later. So we'll get into a little bit about how we use some of these pieces to build Spring Cloud Gateway, and then I'll get to some demo, hopefully. So isn't that a fantastic name? It fits, right? Yeah, it does. Okay. Spring is really good at naming things, right? We get roasted on that a little bit on Twitter every once in a while, but it's very logical, right? I know Phil Webb at one point defended the one particular class that everyone makes fun of, and I can't remember what it is, but like this one, it's describing exactly what it does. This is a handler mapping that uses route predicates to determine where calls should go. So a predicate is a test to see should this web request be included by this route. So there are a list of predicates that can be associated with a particular route, and they can be loaded from various locations. From boot config files, they could come from config server. There's a repository interface that I created, so you could potentially load routes from Cassandra or Redis or any of the other reactive data stores. I am going to focus today in my demos on the Java Fluent interface, which is different than you could do with Zuul 1. So you need to match a route. And basically anything that you can get to in a request, you can use to route to a particular service. In Zuul 1, you had one option, path, right? That's all we got. And we had multiple requests to do it on other things. In Spring Cloud Gateway, you can do path, you can do host, you can do headers, you can do parameters, and you can compose them, right? It's a Java predicate. You can and, or, and not them, and you can get pretty complex with it. So once you have said, okay, here's a request, I've matched all the parameters, then I'm going to enter into the filtering phase, right? So this happens in what I call the filtering web handler, right? So the handler is a Spring 5 interface. It's modeled directly after the WebFlux filter chain. And another key difference here between what we did with Zuul 1 and the gateway is that filters are, for the most part, specific to a route. In Zuul 1, they were just global, and there was a should filter method that says, should I filter this request or not? And so if you wanted to write a filter that sent, customer X to a different cluster, that would be a totally unique filter. And a filter can be both a pre and post filter. And I've got a graphic that displays differently there than it does on my screen here. That's annoying. Okay, basically what happens with a filter is that it's a stack of filters. And as you start to enter this stack, the pre-side of the filters will run. There we go, right? Until you get to the bottom of the stack. And this is where the network call will happen to wherever it needs to go. And then as you come back out of the stack, yeah, see, I've got an extra line there. You'll reach the end of the stack, and those are the post filters, if that makes sense. And I'll show you a little about how that works in a minute. So what kind of things do we have built into Spring Cloud Gateway as far as filters go? We can, what happened? There we go. That was weird. So we can rewrite the path. So this is one of the other requests that we get a lot in Zuul 1 is I want to be able to do something different than just strip the prefix off the path. So if anyone familiar or done any work with mod rewrite in Apache? Yeah, there you go, Mark. Yes, you can finally rewrite the path in the gateway. You can add or remove request or response headers. We do some rate limiting that hopefully I'll show you. Is anyone familiar with Hystrix? Wow, that was a lot of hands. So you can add circuit breaking. In Zuul 1, it was kind of a big ball of mud that I'll show you a nice little picture of, but you can apply that individually. So some routes you might want Hystrix, others you might not. We can integrate with the Spring Cloud Load Balancer client. So this integrates with Eureka, Console, Zookeeper. We have integrations with the Cloud Foundry API. We have integrations with the Kubernetes API, right? You can get services from wherever you need, and we can set up some automatic routes. And if we have time, I'll show you that as well. So I didn't mention this before, but there is a concept of a global filter, and we have a few of those. For example, WebSockets. We have a WebSocket filter. I'll show you a demo of that. And then the filter that currently does the routing is based on Netty. The next milestone will have an option. So currently, what I will show you is based on Netty as the application platform. But in a future version, you could use potentially Tomcat or Jetty to do this as well. So what are some of the benefits? And benefits here are developer experience benefits. Like I said, the Zuul Hystrix ribbon retry was a bit of a mess. It was all or nothing. You could either route using ribbon and get Hystrix or not, right? And you could route directly. You couldn't pick and choose which pieces you wanted, and now you can, which is really, really nice. So let's take a look at just an example of a filter. So I hesitate to ask this. Has anyone looked at this Zuul code in Spring Cloud? Okay, I'm sorry. It's not real pretty. But, so I want you to get excited about this next slide to show you what a difference, 3.5 years of writing this code can do to you. This is a simple filter. Its job is to change the status of a response, right? So the first few lines are actually getting the configuration. And you'll notice it's a factory because each instance of the filter is specific to the route, right? So each one's going to have different configuration. That's why it's a factory and not just the filter. So the actual filter code are these 3 lines after the return. And you can see the chain.filter, right? If I wanted to run pre-code, I would put the code before the chain.filter call, okay? So this is where I would put add request header, right? I would put that functionality here so that before the web requests goes downstream, it would get added. Here you can see I use a reactor operator on the filter chain .then, and I create a runnable or a mono from the runnable and set the response status to the value that was configured. So this is a sample of a post filter. Here is an example of a Franken route, as I like to call it. The reason I call it that is because it has to match all 8 predicates. So in configuration, I didn't want to do, who here is a YAML programmer? Any CF admins out there that are YAML programmers? I didn't want to get into that here to be able to do and, ors, and nots, right? So when you have a configured route in YAML or properties, they're all anded. So for this particular route to match, the host has to match, the path has to match, the method, you can see some regular expressions, right? So that header X request ID has to match 1 or more digits, right? Query parameters have to match, cookies have to match, and it has to be after January 20th, 1900, right? So you could have a filter that runs during your maintenance window that redirects you to, sorry, we're doing maintenance. Even though if you have the correct architecture, you should probably never have those types of banners. Anyway, and then you can see the filters, right? So you can add multiple filters, and they are run in order. So the order matters. You can see a little rewriting the path header. So you'll see that secure headers entry. I read a blog post that said, here are a handful of headers that you should probably apply to every web request because the browsers don't have sensible defaults, and you should set these headers so that you have some sensible defaults. If you go look at the code, there's a link to this particular blog, but it sets all these headers automatically for you, and you can do some configuration on it by properties. But when I saw that, I was like, this is a great way to do some of this cross-cutting security where you could add consistent set of response headers that get sent back down to the browser. And I'll show you in a little bit the Java DSL. And Josh Long did a Spring Tips video on the gateway just last week, and he showed the Java DSL that was then, and I broke it as soon as he released that video and changed the API, but based on the video and based on his suggestions. It used to be that you needed a few static imports to get this to work, and you no longer need that. So it's a little nicer to work with. All right, demo time. Let's see if I can do this. Nice. Great. So, did anyone see Josh Long talk today? Okay, a bunch of you, or previously that wasn't today. Okay, so this can be everybody in the room, right? So, Josh is an expert live coder, right? So, hopefully I can, be half the live coder that Josh is as we go today. So just keep that in mind, right? I'm wearing my tribute to Josh, right? Make jar, not war. We'll get to that in a minute. But actually, before we get to that, I want to make an announcement. The next milestone of Spring Cloud's Finchley.m5 has been released. I get to announce that here today. Yay. This was done in the 2 days after Spring Boot 2 Milestone 7 was released, and yesterday. So it was a very interesting weekend. All right, so here we are. Josh's second favorite place on the internet, right? Start.spring.io. Let's see if you have indigestion. Start.spring.io. If your kids are sad, what are some of the other ones? Anyone? And Josh's favorite place in production? Oh, dang it. On the internet is production. Yeah. Oh well, that was a bomb joke. All right, so here we go. We're going to create a gateway. And you just pretend you don't see any of that. Okay. We're going to call it gateway. We want Spring Boot 2, Milestone 7. We want the gateway. We want reactive web. We want actuator. Eventually I'll show Hystrix. And I'll add Redis, and I'll tell you about that in a little bit. Okay. Generate project. Why is that not? There we go. Whoa. Didn't think you were going to have a psychedelic terminal experience there, did you? Is that big enough? We need a little bigger. Is that good? All right. So we're going to open this guy up just to show you what's included in the POM file here. Spring Boot M7, our newly released Finchley.m5, yay. The gateway, Hystrix, Redis, WebFlux. Okay. Our application. And before, we used to have an annotation here, right? We've seen this with Eureka Server or Discovery Client. There's no annotation. By including the starter, you get the gateway auto-configured for you. Okay? It's a little bit of a change for us, and we're coping with it. So, what do we want to make? Well, the gateway looks for a set of route locator beans. This interface simply has, let me show it to you, a single method, get routes, and it returns a flux of route. Okay, so a collection, multiple routes. So, like I said, we have a locator. In fact, you can load routes from configuration and a database and the Java DSL all at the same time, right? It might not make sense to do that, but you could. So we're going to use the Java DSL. So these are my routes. They're not your routes, but they are mine. I like them. One of the new changes that I made in Finchley.m5 is that the route DSL was a set of static methods. And those have some advantage, but then you lose the benefits of Spring in certain ways as well. So what I came up with is a bean that is the entrance into the DSL. And that way it's hooked into the Spring application context, and the filters and predicates that it finds can be wired up by Spring rather than having to create new objects on the fly that the application context doesn't know about. So we'll name it our builder. And the simple version is the empty set, right? But that's not real interesting. So let's create a route. And this is where I changed it a little bit rather than, anyway, now it takes a lambda for you to build a route, and the type doesn't really matter, but all of the available predicates and filters are now discoverable via the DSL rather than having to know which static class to go into to find the appropriate methods. So you'll see that in just a second. So we're going to create our route, and the first one that we're going to do is what we used to have, right, in Zuul, right? Path-based routing. So we're going to route to a method called /get. Where does get come from? Okay, so if you learn nothing else today, there are two tools that I want you to learn about. The first one is this website, httpbin.org. Anyone heard of it? Yay, good. Lots of you get to learn. So this is a fun little web application in that you can send it a request, and in response, it will tell you about the request that it received. For example, we're going to do a get, and it will return some information about the request, the headers that it received, the origin, the URI that it was sent to it. Incredibly useful for designing APIs and really helpful in designing a proxy, because you can formulate all sorts of requests against it, and assuming they make it through the proxy to HTTP bin, then it worked. So we're going to use that as our target for today rather than, I could go through the steps of building an application, but it's useful to see those headers and that data in the responses. So we're going to route by path, and let's add a filter to this, add request header. We're going to call it SpringOne, and the value is awesome. And then to finish, we need to send it to a URI. So first, so I'm going to, no 3 T's, http.org. Now, normally that would be okay, but we need to add the port here. And the reason we need to add the port is that the gateway takes the existing request and applies this URI to the request URI, replacing the appropriate pieces of it. So in this case, the host will change from localhost, for example, to httpbin.org. But if we didn't add the port of the existing request would be used. So HTTP bin is not listening on port 8080. It needs to listen on port 80. So it's important to include your port here. All right, let's see if this works. It didn't fail, so that's a good sign. So you can see we started Netty on port 8080. So here's tool number 2. HTTPie. Now, I know curl is ubiquitous, and true Unix lovers love curl, but I just don't get it, and I have to look at the help or the man page all the time. So HTTPie is for humans. So my demos today will be mostly with HTTPie, and you'll see the benefits. So that's the command we use, and normally, let's clear that so we get a little space. So normally you would do this, right? Localhost on 8080, and remember, we're going to route by path, right? So /get. Well, like I said, this is for humans, and HTTPie knows that you're going to use it on localhost a lot. So you can do this, which is super nice. So that'll be our shortcut for most of the day today, the rest of the time. So here is our request. You can see some headers that were returned. These were the headers that were sent to HTTP bin. You can see here's the request header we added and the actual URL that was received, right? So we transformed localhost 8080 into httpbin.org port 80, right? Make sense? Great. So next, we're going to do, go away. Is that bigger? That'd be a little bigger. We're going to add another route. We're going to do host routing this time. Remember, I mentioned that we get to use some of Spring's path matching capabilities, so I'll show you a little bit right here. Pattern we want to match. Now, this isn't a true path, but a host name is hierarchical, and so it does follow. You can match not on slashes, but on dots. So we're going to match myhost.org. Any Queen fans out there? And again, we're going to go to HTTP bin. We'll restart. Yes, don't show me that again. So I want to show you a different method, one that was available from HTTP bin, but we haven't mapped, right? So this should result in a 404 because there's no matching route for slash headers, right? Just to prove that I'm not lying. So there's our 404, there doesn't exist. It needs the host header, right? So HTTPie again to the shortcut rescue. This is how you define a header. So now this should match and should forward it on, okay? And there we go. And there is our another one, Bites the Dust. I don't know why I thought of that, but it's a great song. All right. Our next route, we are going to show you a little, I'm going to do most of the path matching from here on, most of the predicates based on host, just because it's simple and it doesn't matter the path. So I'm going to do rewrite.org. But you could do, right, again, oh, wrong key. Just to show you that you can do or path, right? So you could hop in and do some complex predicate matching here. So I've showed you that you could use all the built-in predicates. Well, what if you wanted to write your own predicate? How would you wire that in? So you can just, excuse me, didn't want to complete. Well, I'll find that later. Sorry, I was hoping to show you something that doesn't look like. Oh well. So if you had a custom filter, you could say here's a filter and give it an instance of a filter right here. And that should be available for predicates as well, right? You should be able to supply your own into this DSL without having those automatically discovered on the DSL. Okay, so we're going to rewrite the host, rewrite path, and I'm sure there are some of you here that can conjure regular expressions out of thin air. I cannot, so there we go. And I'll talk you through that a little bit. And of course, we're going to HTTP bin. So these are standard Java regular expressions. Here we are saying match something that begins with /foo/, and then we are going to capture this piece right here, and we are going to name it segment, right? It's just an arbitrary name, nothing to that, right? And we're going to just, basically we're going to strip the path off the front, right? We're just going to strip foo off and just replace it with the named segment. Okay? Let's go ahead and restart. So again, if I go to /foo/get, we get a 404 because we didn't match. Rewrite.org. And there's the slow internet, conference internet, right? But it did work, right? So we eventually got through, and it rewrote the path to get. There's also another version of this called setPath, which you could, well, I was just going to talk you through it, but I may as well show it to you. Setpath.org. That's why I wanted to do. Well, maybe I'll get into path equals anything. This is not practice. This is not part of my usual demo, so we'll see if this works. So basically, as I match a path, I can say, match this particular segment, right? This is the same thing that Spring's handler mappers use when you specify segments like that in a request mapping. And then in the set path filter, I can say I want the path to just be segment. So let's see if this works. So again, we need to match on foo, but this time it's setpath.org. And there we go, it worked fine. Okay, so I wanted to show you Hystrix and what that looks like. So we're going to show you Hystrix timing out, right? So one of the things that the circuit breaker provides is the ability to time out, right? So that you don't spend all of your time blocking on a particular call. So hystrix.org. Thank you. Let's see. And we want to have Hystrix. And there are two options here now. There only used to be one. You can do a setter, which is Hystrix imperative style of configuring a Hystrix command, or you can just give it a name and use properties to configure that command. Again, we'll go to HTTP bin. Go ahead and restart this guy. One of the methods that HTTP bin provides you is a way to simulate slow calls. So this delay says block for 3 seconds before returning. And we'll, of course, match on hystrix.org. And you'll see we get a gateway timeout, right? Hystrix said, I'm done. I got a timeout. Let's spit out a 504 to the client. And if that happened enough times in a short period of time, the circuit would open and it would just return a 500 error, right, as per the standard Hystrix behavior until such time that the downstream service kind of came back to life. All right. Next one. So one of the features that we get asked about is WebSockets, right? This is something that is a long-lived connection, and I want to thank some of the Spring folks that helped me to get this right. But one of the things that being based on Reactor and WebFlux gives us is the ability to have long-lived connections. And I was able to reuse the connectivity, the WebSocket facilities in Spring 5 to add those to the gateway. So what I'll show you here is that we're going to match on a path called echo. And the URI, now we're no longer going to go to HTTP bin, but we're going to go to a WebSocket server, localhost port 9000. Okay, so we are going to do a little split terminal here. Awesome. It's about the same size. So I'm going to show you this little command I have written. there's a little tool called WSCat that is very useful in debugging and writing not only web service clients, but also servers. So I'm going to start a little WebSocket server, okay? So this is what I'm going to proxy to. So WS server, running on port 9000, right? Now there's also a client side to WSCat. Let me show you. Oh, I didn't want to run it, I wanted to show it to you. I got to prove things. So this says connect to WebUS localhost port 8080, right? This is the gateway, not the web service. I'm not faking it, going directly to the web service server, okay? So we'll run that. And so I can say hello. The server received the message, and I can then go the other way from the server, and the client received the message. So we just had two-way communication through a long-lived connection through the gateway, right? WebSockets through Spring Cloud Gateway. Woohoo! All right. For that, let's see. We're done here at 5:30, is that right? Heads nodding, yes? Yes, okay. Well, why don't we finish up and get ready for some questions. Come back to the presentation. So you want to talk a little bit about your upcoming session?
Yeah, so there is another session on Cloud Foundry UAA as an identity gateway. So I touched upon the security patterns. So we'll take a closer look at how the different security patterns can be enforced through Cloud Foundry UAA using the API gateway pattern. So that talk is on Thursday, 11:15, room 2004.
So these slides are at this particular URL. They're also available at my blog at spencer.gibb.us. You can find us on Twitter here if you need any information. Wanted to open it up to any questions you might have here in the front row. The question was if there is any planned integration with Spring Cloud Services on PCF, and well, the honest answer is I'm not sure. We have been talking about it. We'll let you know. I know the project manager for that is here. If you find him, you could go ask him, and he'd probably be able to give you a better answer than me. Yes?
Do you have an integration with Eureka?
Yes. So that's what I was hesitating to demo to you, whether or not I should show you that. One of the things I can show you is that, yes, there is integration with Eureka. And so what your URIs would look like here is, and thank you for asking that question. I should have at least showed this part. You would say, route to the load balancer for my service, right? And this would say, get the host port and scheme from service registry, replace that with whichever server it chose, right, through the load balancer algorithm, and then it would use that. So yes, we do have that. Yes? The answer is, can you split traffic 60-40, 50-50 to different versions of a service? We don't have anything like that built in, but I don't think it would be hard to do that in a filter. Basically, you could read the metadata of the service and say, is this version 1, version 2, and then set some properties. It really wouldn't be too hard to do that, but nothing built in. Yes, here in the back. What's going to happen with Spring Cloud Zuul? Good question. So Spring Cloud Zuul is still in the Finchley milestone. We're not going to remove it. We have large enterprise customers that have built lots of custom filters. So as long as they're on it, we will support it. So in the future, we may think of see if we can come up with a compatibility layer that allows you to use your old filters maybe in a new, that's something we've talked about, but we'll support Zuul 1 for a while. Let's try this side. Sorry, I've been focusing over here. Yes, so the question is, can you support security like JWT tokens, right? The answer is yes. We still have some work to do because we have some of that functionality with Zuul. So we are working on porting that. So the other part of Spring, the Spring ecosystem that is new is Spring Framework, Spring Security 5. And so we have to work with them to get our ducks in a row there. Yes? So the question is about Netflix Ribbon, and so I guess I didn't mention that here. When it sees LB, it actually uses Ribbon to select the server, so the answer is yes. Another feature that I was planning on showing you that I did not is the Redis rate limiter. All right, so we have some built-in rate limiting that comes from Stripe. I don't know if you've heard of the payment processing company Stripe. So they did a nice blog on 4 different styles of rate limiting, and they use Redis and its Lua scripting capabilities, and so we brought that in. I was particularly keen on that because we have reactive Redis support, right? So non-blocking Redis support that we're able to use and get rate limiting to show you here. If you go watch Josh's Spring Tips on that, he demonstrates that. More questions over here in the front? So the answer is the facility that used to make the outbound call replaceable? The answer is yes. In fact, I have a replacement already written. So the current implementation that we saw today uses Netty, but I have an implementation that will be, you can do some configuration and be able to use Spring's web client to do the HTTP, but you could certainly replace it with whatever else as long as it is also non-blocking. It certainly could, yes. Right behind, yeah. So asking about gRPC support here, you could certainly do that. It would have to be a separate filter that understood gRPC, but I have an open issue for that already, but that might not come in the initial release. Other questions here? Say that again? The question is supporting only Redis for rate limiting. So the current implementation is all we have is Redis, but it's an interface, so there certainly could be anything else, right? You could do it, again, as long as it's non-blocking and you have reactive access to it, you could store it in anything that worked that way. So yes, there's a possibility. We haven't done anything else. So we support Redis on PCF, so that was one of the things we wanted to target. But yeah, if you have an idea of something, go ahead and file an issue and we can look at a different implementation. Any other questions? Yes?
Have you done any kinds of performance
comparisons. So we had a user do that, and there were a few things that we needed to fix, but I don't anticipate any problems that way. It should be, if you go look at one of the talks by one of the Netflix engineers about Zuul 1 and Zuul 2, they talk a little bit about the performance differences between the blocking I/O and non-blocking I/O, and in certain workloads, non-blocking gives you a certain measure of performance increases. So we have some things to work on there, but I don't see any problems working or getting over those problems. Yes?
Is the rate set used to one, two instances in a cluster?
Yeah, so the reason that we use Redis is that you would generally have a cluster of gateway servers, right? And you want the statistics for the particular key to be available across all of them. That's why we've used Redis. Yep. I think we're out of time. If you want, you can come ask questions afterwards. Thanks for coming. Appreciate it.